Hello, my magnificent math students. Today we're going to continue solving equations, but now we're going to have variables on both sides of the equal sign. So I've got a visual here to maybe help you to see what's happening on these. The question marks are like your x's. So on the left side, I really have 2x plus one of those circles is just 1. And on the right side, I have just an x, 1x, plus 3. We haven't solved those kind of equations yet this year, but we can solve these. And I'm going to use this actual visual here so that we can kind of see what's really going on. If I would take one of the x's, one of the question mark boxes away from both sides, as long as I do the same thing on both sides, it's okay. And then I could also take off this circle with one of these circles. And what that leaves me with is that this x is really equal to 2. Now, this visual works because we had all positives and because it was all drawn out nicely. I really don't want you to have to draw out a visual for every time we solve an equation, but I have another visual to just kind of help you to maybe see what's going on. Here we have like a two-pan balance, like you would use in science class. And the cylinders, the green cylinders, are like x's, and the purple cubes are like 1s. So again, on the left side, I have x plus 5, and on the right side, I have 3x plus 1. What I can do with this interactive scale is I can remove things from both sides of the equation of the two-pan balance, and it'll still stay balanced if I remove things that match. So for instance, I can take off one of those cylinders on the left, and then I can do the same thing on the right. Well, now I don't have any other cylinders, but I could take that cube away. Now you notice it's not balanced. So if I take away one of the other cubes, now it is balanced. Now I'm down to 2 of the cylinders equals 4 of the cubes. If I get rid of one of the cylinders and then 2 cubes, that balances it again. So what I can see right now is that that cylinder, the x, is really equal to 2. So that's just another way to see that. And when we are solving these equations, as always, the big thing for us is you have to show all of your work. Again, we won't have those scales set up for every single problem, but we will have our methods that we've been using so far for how to show our work. So these first couple of problems I'm going to go through, you don't have to write these down as examples. You realize that you certainly can, but I want you to notice that now, again, I do have variables on both sides of the equal sign. That's our new thing. I would also say that I don't want to see a subtraction right here. I would want to change that to a plus a negative 2. Do a keep, change, change. Now, typically, my question is going to be, where are there fewer? Where is the smaller number of x's? So on the right side, I've got a negative 2x. And on the left side, I've got a negative 2x. On the right side, I've got a negative 7x. Negative 7 is smaller. Typically, I would move that 1, even though I haven't showed you any of these yet. But if I move that, does everybody agree that if this went away, there would be nothing left on that side of the equal sign? Not that it can't be done that way, but I would have to put in a 0 and kind of move some stuff around. So I'm going to move the negative 2x instead. So what I want to do is I want to get rid of a negative 2x. And to do that, I'm going to use the opposite. I'm going to use a positive, or I'm going to add 2x. And as long as I do the same thing on both sides of the equal sign, it's still balanced. So this negative 2x and a positive 2x, or adding 2x, does cancel out. So I'm left with 15 equals negative 7 plus 2 is going to be a negative 5x. And at this point, we should be pretty comfortable with this part. So x is going to be negative 3. When we're solving this problem, I've got distribution on both sides of the equal sign. So let's start with our distribution. And I would say I want to do a keep, change, and same thing right here. So negative 2 times x, negative 2x, easy. Negative 2 times negative 5 is going to be a positive 10. 6 times 2 is 12. 6 times the negative 1/2 x. Since they're different signs, I know it's going to be a negative. Half of 6 is 3, so this is just going to be a 3x. Now, this one I am going to follow my rule. So I'm going to ask, which one's smaller, negative 2x or negative 3x? And again, if that still confuses you a little bit, think about temperatures. Negative 3 is colder than negative 2 because it's a smaller number. So usually it's the smaller one that I want to move. So I want to get rid of the negative 3x. I'm going to use a positive or add 3x to both sides. Notice how I'm lining up my x's. I'm not going to put my 3x here underneath my 10 because that doesn't go together. They're not like terms right there. So negative 2x plus 3x is 1x or just x. I still have a plus 10 and I have a 12 on the right hand side. So I'm going to get rid of the 10. And then I'm going to ask, because I already said it once, do I really need the 1 in front of the x? And no, I don't. It's just going to be an x. If you put a 1 there, it's fine. I wouldn't mark it wrong. And some people even take the step and divide by 1, which doesn't change anything. So that kind of takes extra steps that you don't really need to do, but it would be perfectly fine to do them. I would suggest that you write these down in your notebook. If I go too fast, remember that you can pause the video and get caught up whenever you need to. On number 1, I'm going to sneak a 1 in front of that x. If I ask which one is smaller, 1x or 9x, the 1x is smaller, and it's a positive 1x, so I would want to subtract 1x to get rid of it. So on the left side, I just have 16, and 9x minus 1x is 8x. And we divide by 8. So x is going to be 2. In this problem, for number 2, I would change this to plus a negative 70, keep, change. Looking at my y's, the smaller y is the 4y. So I'm comparing 4y and 12y. 4y is smaller, and it's a positive 4y, so I'm going to subtract 4y. And I hope that you're understanding why I'm subtracting. 4y minus 4y, there are no y's left on that side now. So that's gone. So I have negative 70 equals 12y minus 4y is going to be 8y plus 2. And then right now you should be good with this. Subtract 2, do a keep, change. So that's going to be a negative 72 equals 8y. And divide by 8. Remember, you can check any of these by just substituting your variable back into your original equation. Let's go back to number 1 to check it. If I put the 2 in for the x, I would have a 2 right here, so I would have 2 plus 16, well, that side's 18. And over here, 9 times 2, that's also 18. Those are equal. Okay, next 2 problems. So I'm going to distribute first. I've got 5p plus 30 equals 8p. And now the smaller variable is the 5p, so I'm going to subtract 5p. So I get that 30 equals 3p. And then I want to divide by 3. So p equals 10. And again, if I check that, if p is 10, inside the parentheses, I would have 10 plus 6 is 16, times 5 is 80, and 8 times 10 is also 80. Distribution on both sides of the equal sign this time. I'm going to have 3g, do a keep, change, plus a negative 21, equals 20 plus 2g. And which g is smaller? The 2g is. I'm always going to want you to move the variable first before you start moving other numbers. Because if you move other numbers, then sometimes you don't end up moving the variable that you really want to move. So I'm going to subtract 2g. 3g minus 2g is just 1g, or just g plus a negative 21 equals 20. So then I would add 21. I'm concerned that some people would see the 20 and the 21 and assume that the answer is either going to be 1 or negative 1. But we have to be really careful here. Because it was a negative 21, we do have to add it. So I'm going to get 41 for G. Sometimes we do get decimal problems or fraction problems. So when I'm looking at this problem, I would start by changing my subtraction with a keep, change, change, and variables first. On the left, I have a positive 7n. On the right, I have a negative 4n. Negative 4 is much smaller than positive 7, so I'm going to get rid of this. And since it's a negative 4n, I'm going to use a positive 4n, or adding 4n to get rid of it. So I have 1.8 plus 11n equals 9.5. Now, when I subtract my 1.8, feel free to use a calculator on this if you'd like, but we're going to be doing some borrowing here, so it's going to be an 8. 15 minus 8 is 7. 8 minus 1 is 7. There's my decimal. And when I divide by 11, I get that n equals 0.7. All right, everybody's favorite, fractions. Now, take a look at the variables. I know that they're both fractions, but you can see that one of them is a positive 3/7 W. The other one's a negative 4/7 W. Clearly, a negative number is going to be smaller. I do tend to not move this variable just because there's nothing left there. I would have to put a 0 there and then move something to that side anyway. And I do see a lot of people make mistakes when they do that. They forget about the 0. They just kind of slide their equal sign over and they make some mistakes on that. So I'm going to move the 3/7 W. It is a positive, so I'm going to subtract or use a negative 3/7 W. And you're going to see, even though this was a fraction problem, it's really a pretty nice fraction problem. I forgot to do my keep, change, change right away, but there's my negative 11. Negative 4/7 W plus a negative 3/7 W, that's going to be negative 7/7 W, which is kind of ridiculous to write it that way. We would just say that that's just a negative 1 W. And then I would have to divide by negative 1, which gives me 11 for my W. We've got this one story problem today. I know that this problem seems unrealistic because this isn't really how we watch movies anymore, but there used to be things like movie clubs and tape and CD clubs, and you would have to pay a membership fee or you'd be able to buy them with a different price or whatever. So in this problem, it says one movie club charges a $100 membership fee and then $10 for each movie. So if you're buying movies, $10 is a decent price, but you have to pay the $100 to start with. Another club charges no membership fees, but they cost $15 for each movie. I want to write an equation to figure out how many movies I would have to buy for them to be exactly the same. So let's use M for the number of movies that they're going to buy. In the first club, there's a $100 membership fee. That's just automatic. And then it's $10 for each movie. So it's $10 for every movie that you buy. In the second membership club, there's no membership fee, but there's only or it costs a little bit more, $15 for each movie. Once we have this should be a pretty easy problem to solve at this point. I want to move my smaller variable, which is the 10m, so I'll subtract 10m. and I get 100 equals 5n, and divide by 5, m equals 20, which means that if you would buy 20 movies, it wouldn't matter which club you were in. It would cost exactly the same amount of money. Today's learning check is going to be different than other ones. It's not just fill in the blank or a multiple choice. You're going to have to show some work by typing, which I know is going to be kind of weird. So I did an example problem here to show you this. This is what the problem will look like. This isn't the exact problem, but that's what it's going to look like for your formative learning check today. When I'm solving this, I'm going to ask you, I know we won't have the vertical line, we don't have the horizontal lines, but each line you're going to show one step of work. So if you're comparing your n's, the 7n is smaller, so you would subtract 7n over here, and then if you do that, you also have to subtract it over here. So I want to see it twice. And then I want you to write down what you have left over. Now I'm down to 2n minus 2 equals 50. To get rid of the subtracting 2, I would add 2 to both sides. When I do that, I'm down to 2n equals 52. So you can see I'm writing down what I have after each step. Typically, we would show this as a division with just a fraction bar. Right here, we would divide by 2 and divide by 2. But that's not an easy way to type that for you. But there is a regular division sign that you can do. So you're going to divide both sides by 2, and then we get down to this final answer. This is what your learning check is going to be like today. It's only one problem, but you have to type all this work in. So today you're going to have, for your practice problems, a worksheet that's called variables on both sides. It's day 1, because we're going to spend more than one day on this. Make sure you show all of your work. And I mean all of it, everything. And then when you take the learning check in Schoology, you have to type all of your work. And that again means typing all of your steps, once on the left side, once on the right side. If you have any questions, make sure you ask me, and good luck.